Now, hello students. In this part of aerosol, I'm going to cover the manufacturing and accuracy test. Manufacturing of pharmaceutical aerosol includes main three parts, and this manufacturing of pharmaceutical aerosol is the most IUPAC point of view. It includes pressure filling apparatus, cold filling apparatus, and compressed gas filling apparatus. First, pressure filling apparatus. This consists of pressure burette capable of maintaining small volume of liquefied gas into the aerosol container under the pressure. Propellant is added through an inlet valve located at the bottom or top of the pressure burette. The propellant is allowed to flow with its own vapor pressure in the container through the aerosol valve, and the trapped air escape out from the upper valve. The propellant stops flowing when the pressure of the burette and the container become equal. If the further propellant is to be added, a hose leading to the cylinder of the nitrogen attached to the upper valve, and pressure exerted by the nitrogen help to move the pressure into the container. Another pressure filling device makes use of piston arrangement and is capable of maintaining positive pressure. This type of device can be used for filling inhalation aerosol which have metered valve. Procedure. This method involves the filling of concentrate means API and other excipients into the container and at the room temperature. Then the valve is placed in the container and cranked. Through the opening of the valve, the propellant are added, or it can be added under the tap. Since the opening of the valve are smaller in the size ranging from 0.018 to 0.13 each, it limits the production and the process becomes slow. But with the use of rotary fill machine, newer filling heads where the propellant are filled through the valve fill and the production rate is improved. Obviously, our aim is to increase the production again. The trapped air in the container and the air present in the headpiece is removed before filling the propellant to protect the product from the getting adversely affected. How it adversely affects from the headspace filled with the air? If the head in the air, there is oxygen, there is interaction between the API with the oxygen, and it is going to decrease the efficiency of the API. Various units used in pressure filling line are arranged in the following order: unscramble, air cleaner, concentrate filler, valve placer, flanger, valve crimper, propellant filler, water bath, leveler, coder, and packing table. Purger, valve crimper, and pressure filler are replaced with the single unit if filled in a case bag under the case method. Advantage of pressure filling. Solution emulsion suspension can be filled by this method as chilling does not occur. Contamination due to moisture is less. High production speed can be achieved and loss of propellant is less. Disadvantage. Certain type of meter valve can be handled only by the cold filling process or through use of an under the cap filler and valve crimper. Process is lower than cold filling method. Here are the example of, in the right hand side, the example of pressure with 1, and here is the example of this equipment. Now next is the cold filling apparatus. It consists of an insulated box fitted with the copper tubing, and tubing are coiled to increase the area exposed to the cooling. The insulated box should be filled with the dry ice or acetone prior to use. See, here is the cold filling apparatus. Okay, this you have to draw during the exam also. The apparatus can be operated with or without metered valve. The hydrocarbon propellant can be filled into aerosol container using this apparatus because large amount of propellant escape out and vaporize. This may lead to formation of explosive mixture. Pure carbon vapor do not form an explosive or flammable mixture though their vapor are heavier than air. Procedure. Non-aqueous products and products which can withstand the low temperature at -40°F are used in this method. The product concentrate is chilled to the temperature of 40° and filled into already chilled container. There is a chilled propellant is added completely in one or two stages depending on the amount. Another method is chill both the product and concentrate propellant first in the separate pressure vessel at 40 degree and then fill into the container. There are two methods. One, either we can chill separately and we can add the concentrate and propellant separately, or initially we mix product concentrate and propellant and then we can fill in it. The valve is placed and crimped on the container. Then test for the leakage and strength of the container is carried out by passing container into the heated water bath where the content of the container are heated to 130 degrees Fahrenheit. After this, the container are dried, capped and labeled. Various used cold filling methods are given here. The cold filling method is no longer being used as it is being replaced by pressure filling method. The advantage is easy process, but disadvantage are aqueous products cannot fill, emulsion and dust products exactly affected by cold temperature cannot fill by this method. Here this is the diagram of the cold filling apparatus. Compressed gas fill apparatus. Compressed gas have high pressure, hence a pressure receive valve is required. The apparatus consists of delivery goes. The flexible hose pipe which can withstand 150 pounds per square inch gauge pressure is attached to the delivery gauge along with the fill head. A flow indicator is also present in the specialized equipment. The procedure. The product concentrate is filled into the container. Valve is used and crimped on the container with the help of vacuum pump. The air is removed from the container. Filling head is put in the opening of the valve and the valve is depressed and the gas is allowed to flow into the container. The gas stops flowing if the delivery pressure and the pressure within the container will become equal. Carbon dioxide and nitrogen oxide is used if more amount of gas is required. High solubility of the gas in the product can be achieved by shaking the container manually or with the help of mechanical shaker. Now comes the quality control test of aerosol. Includes propellant, valve, actuated tube, container, weight checking, leak test, and spray test. Propellant. We have to test the propellant, the identification and purity except to use that for the identification chromatography and air spectroscopy is used, and for purity and acceptability, moisture, hydrogen and non-volatile residue determination. Valve actuated tube. Sampling is done according to the standard procedure, and for metal dose aerosol valve test method are developed by Aerosol Specification Committee, Industrial Pharmaceutical Technology Section, Academic of Pharmaceutical Science. The objective of this test is to determine the magnitude of valve delivery and degree of uniformity between individual valves. Standard test solutions were proposed to rule out variation in the valve delivery. Test solution. Here are the various ingredients. Test 1, test solution B and test solution C. Testing procedure. The test 25 valve placed on the container filled with the specific test solution, actuate 8 and temperature VO2 that is 25. Valve is attached to the fullest extent for 2 seconds and wait. Again the valve is actuated for 2 seconds and wait. Difference between them represent the delivery in the milligram. And with the use of this equation, and if there is a limits are also given, if there is a change in the limits, then it is not acceptable. When 50 individual delivery, if 4 or more are out of the limit, valve are rejected. If 3 delivered are outside limit, the 25 valve are tested. And lot is rejected if more than 1 delivery is outside the specification. If 2 delivery from 1 valve and beyond the limit, another 25 valve are tested. Lot is rejected if there is more than 1 delivery is outside the specification. Container. Container are examined for the defects in the lining. Quality tests include degree of conductivity of electric current as a measure of exposed metal. Glass container examined for flow. Weight checking. In is done by periodically adding to the filled line that empty aerosol container with after filled with the concentrate are removed and weighed. Same procedure used for checking weight of propellant being added. Leak test, same. It is means of checking crimping of valve and detect the defective container due to leakage. Is done by measuring the crimp dimension and comparing. Final testing of valve close is done by passing the filled container through the water valve. Spray test. Most pharmaceutical aerosols are 100% spray test. This serves to clear the deep tube of pure propellant and pure concentrate to check for the defect in the valve and spray. If see now is the evaluation of the test or pharmaceutical testing. Another name is the pharmaceutical testing of aerosol. QC test, if they are asking for the QC test, then we have to write another whatever we had explained till now. And pharmaceutical testing or aerosol testing or evaluation test, so you have to write all these things. Flammability and combustibility test, flash point, flame projection, and various physicochemical characteristics. Performance and biological testing. We are going to see one by one in detail. Flammability and combustibility. The apparatus used, that is take, open cup apparatus, all these are the GPAT point of view very important. Product is chilled at 25 degrees and test liquid temperature is allowed to increase the flow and temperature which vapor ignite is called flash point. Flame projection. Product is sprayed for 4 seconds into flame and the flame is extended and exact length is measured with the ruler. Physicochemical characteristic, various properties and various methods used to identify that vapor. So for that, pressure gauge, density, hydrometer or pygnometer, moisture, calcifer, gas chromatography, aerosol propellant, via gas chromatography, and ISO2. Performance, aerosol valve discharge rate, how much amount of that is discharged, content of aerosol product of the known weight is discharged for specific period of time by reweighing the container after time limit. The change in the weight per time distance give the discharge rate and that we have to measure in gram per second. Spray pattern. The method is based on the imprinting of spray on the piece of paper that has been treated with the dyed talc mixture. The particles that strike the paper cause the dye to go into the solution to be absorbed on the paper, giving the record of spray for the comparison purpose. Dosage with the meter dose. Reproducibility dose can be determined by assay technique, that you know, an accurate weighing of filled container followed by dispensing of the several doses. Net content. That can that have been placed onto the filled line are weight and difference in the weight equal to the net weight. Foam stability. Method. Visual evaluation. Time for giving mass to penetrate the foam. Time for giving growth, that is insert into the foam to form. And a rotational viscometer we can use. The next is particle size determination. Method used, that is cascade impactor, light scattering. Cascade impactor. There is principle of cascade impactor. Here is the diagram of cascade impactor. Cascade impactor and light scattering. The stream of particle projected through the series of the nozzle and the glass slide at high velocity. Larger particle impacted first on the lower velocity stage and smaller particle collected at higher velocity stage. Light scattering. An aerosol settle under turbulence condition and the change in the light intensity of the tint is being measured. Biological testing. Therapeutic activity and toxicity. For inhalation aerosol, dosage of the product is determined and is related to the particle size distribution. Topical aerosol is applied to the test area and absorption of therapeutic ingredient is determined. For inhalation aerosol, exposing test animal to vapor spray for the aerosol container and topical irritation and chilling effect are determined. That's all about the pharmaceutical testing of aerosol.